Hi, this is Leetcode question, difference between maximum and minimum price sum, and this is the last question of weekly contest 328. There exists an undirected and initially unrooted tree with n nodes indexed from 0 to n minus 1. You are given the integer n and a two integer arrays edges of or a 2D integer array edges of length n minus 1, where edges of I equal ai pi indicates that there is an edge between nodes ai and bi in the tree. Each node has an associated price. You are given an integer array price where price of I is the price of the ith node. The price sum of a given path is the sum of the prices of all nodes lying on that path. The tree can be rooted at any root of your choice. The incurred cost after choosing a root is the difference between the maximum and the minimum price sum amongst all paths starting at root. Return the maximum possible cost amongst all possible root choices. For example, we have this tree, and this tree has n equal 9. That means we have 9 nodes from 0 to 8. So this is node 0, 1, 2, 3, 4, 5, 6, 7, 8. And each node has a price. So the price of node 0 is 9. For node 1 it's 8. For node 2 the price is 7. For node 3 price 6, and so on. Now we need to return the maximum possible cost amongst all possible root choice. So for every root we need to find what is the cost of the root, and the cost of the root is the difference between maximum path sum and minimum path sum. For example, let's take or consider the root to be node 0. The minimum path from this node to any other node is the node itself, because this will be the minimum path sum. So minimum path sum for node 0 is the price of the node itself, which is 9. The max path sum will be the path sum of one of the paths to the leaf nodes. For example, from node 0 we can go to this node, to this leaf node, and the path sum for this path is the sum of the prices, which is 3 plus 1 4 plus 9 is 13. Another path from the root 0 is this path. It's from the root to the leaf, and the sum of the prices in this path is 15 plus 9, which is 24. We have also this path to this leaf node, and the price or the path sum of this path is 7 plus 8 15 plus 9 24. We also can have this path to this leaf node, and for this path the sum is 10 plus 6 16 plus 8 24 plus 9 is 33. Another path we can take from 0 to 1 to 3 to 5, and the sum for this path is 5 plus 6 11 plus 8 19 plus 9 is 28. So for all the paths to leaf nodes we have these path sum 13, 24, 28, and 33, 24, and the maximum is 33. So max path sum equal 33. So the price sum of the or the cost of the root is the difference between the max and minimum price sum. Max is 33 and the minimum is 9, so the cost for root 0 is 24. Now we need to check this for every root and see if we can get better or greater than this value. For example, if we take another node and consider it as root, let's take node 8 to be the root. The minimum path from this node is this path, which is the root itself, or the price itself, which is 3. So the minimum path sum equal 3, and maximum path sum will be one of the paths to leaf nodes. So for example, we can go to this leaf, and the path sum in this path is 3 plus 1 4 plus 9 13 plus 15. This is 28. Another path is going from 8 to 7 to 0 to 1 to 2, and the sum for this path is 7 plus 8 15 plus 9 24 plus 1 25 plus 3 28. Another path is from 8 to 7 to 0 to 1 to 3 to 4, and the sum in this path is 10 plus 6 16 plus 8 24 plus 9 33 plus 1 34 plus 3, this is 37. Another path will be from 8 to 7 to 0 to 1 to 3 to 5, and the cost for this path, or the sum in this path, is 5 plus 6 11 plus 8 19 plus 9 28 plus 1 29 plus 3 32. So we have these values for paths from root 8, 32, 28, and 28, and we have 37, and the maximum is 37. So max path sum equal 37, and so the cost for node 8 is equal the max path sum minus min, which equal 34, and this is better answer than the previous route. Now if we take another route to find better answer, the maximum will be this route, because this route, the min path is the price, which is 5, min equal 5, and the max will be this path, which has the sum 5 plus 6 11 plus 8 19 plus 9 28 plus 15. This is 43, and this is the maximum path amongst all the paths to the leaves. And so the cost for this route is 43 minus 5, which equals 38, and this is the max cost amongst all the root, and this will be the answer for this example. Now how can we solve this problem? First of all, we need to for every node we need to know the maximum subtree sum for every branch. So for node 0 we have this branch, we have this, and we have this. Now we need to know what is the sum or the max sum in this branch, and for this branch, for this branch. So for this one, up to the leaf we have 1 plus 3, 4. For this branch we have one node, which is 15, and for this branch we have this path is the maximum. So 10 plus 6, this is 16 plus 8, 24. So for the 3 subtrees we have values 24, 15, and 4. And for node 0 we need to store the maximum 2 values, the max and the next max. So for node 0 we will store in a table here called max subtree. For node 0 it will be 24, which is the max, and 15, which is the next max, and we repeat this for all the node. So this is 24, 15. Now for this node 1, we have this branch and this branch, and for this branch the path sum to the leaf, or the max path sum, is 7. For this branch it's this path, which is 6 plus 10, which is 16, and that means we have only 2 values, and the max is 16 and the next max is 7. So this what will this table store for node 1, and for node 2 we have no branches, there are no subtrees, so we'll store 0 and 0. For node 3 we have these subtrees, and the max for this one is 10 and the max for this one is 5, so we will store 10 and 5. For this node we don't have subtrees, so we store 0, 0. Now for this node we have only this subtree, and the path to this subtree is, or the max path for this subtree is 3. So we have 3 and 0. So this will, what will max subtree store for every node. And to fill this table we will use depth first search. We have this function, the fs1, and this is the implementation. So we loop over all the neighbors of the node, and if the node equal parent we will skip it. For example, if we visit from 0, go from 1. Now while we are at 1 we don't want to return back to 0, and we have these 2 conditions to check if the value, or to compare them with the max and next max sum, and at the end we store the value in the table as a pair, max sum and next max sum, and these will be the values for this example. Now next what we need to do, so the time complexity for this stage is big of n, because we visit every node just once. Now after we calculated the max sub-tree table, which includes the max path sum and next max sub values, we need to calculate the cost of each route, and to do that we need to do another DFS function. And remember, the cost for any route is the difference between the maximum and the minimum price amongst all paths. So we start at route 0. Now at route 0 we know the maximum is 24. This is for the maximum sub-tree, which is this one, plus 9. So this will be the max path sum from this route to any leaf node, which is the max path sum from this node plus 9, minus minimum path sum is the price of the node itself, and this equal 24. So for route 0 the cost is 24. Now we need to calculate the cost for this one, because we are doing depth first. So we are going to visit node 1, and this node we have information about these two branches, but we don't have information about this branch. And so before visiting this node from the parent node 0, we need to do or to provide this node with the cost of this branch. And to do that, we have these two values, 24 and 15. We need to check if the node 1 we are visiting is contributing this to this 24, or if this 24 came from this sub-tree, this direction. In that case, we will take 15 plus the price of the parent. If not, we will take 24 plus the price of the parent. And to do this check, we simply take the max sub-tree of this node, which is 16 plus the price of this child or neighbor is 8. We need to check if equal the max value, which is 24, and the answer is yes. So in this case, the cost for this branch will be the next max value, 15 plus 9, which is 24. So when we call DFS to node 1, we will pass this branch sum to be 24, and this is what we are doing here, this if else, and we pass branch parent branch sum. Now at node 1 we need again to calculate the cost for this root node 1, and we have information about this and about this and about this coming from the parent. So this was 24, and we have 16 and 7. We take the max, which is 24, and plus the price of the node is 8, minus the min path sum, which is 8, equal 24. So this is the max branch sum at node 1, and this is the min, and the result is 24, and this comes from this path. The path sum for this path is 8 plus 9, 17, plus 15 is 32, which is this value, max path sum, and the min is the price of the node of itself. And so for root 1 the cost is 24 also. Now we need to visit from 1 to 2, but before we are doing that we have information about the child, which are 0 0, and we need to provide node 2 about the cost of this branch, and we do the same check if the 16 is coming from this branch while we are at node 1. And to do that we have the max sum at node at the child or the neighbor is 0 plus the cost or the price of node 2 is 7. Is this equal the max 16? The answer is no. In this case we will pass this max value 16 plus price of the parent 8 equal 24, and this means the max path sum at this branch, if this is the root, is 24. So now we are at node 2. At node 2 we have these three values, 24 0 0, and the max is 24, and so the max path sum for or the cost for this root will be 24 plus 7 minus 7, which is 24. Now also remember at node 1 we are done with this branch. Now we need to visit this node, and we do the same calculation for everything. And here is the implementation of this function. So this is parent branch sum, initially comes from node 0. So here we pass node 0, and the parent branch sum we calculate it here. Now for every node, for every child, if child equal parent, we continue because we don't want to return back to the parent. Otherwise we need to calculate the parent branch sum for next node we are visiting. So if we are here, we need to tell this node what is the cost of this branch or the max path sum of this branch. And to do that, again, as we said, we need to check if this branch makes the max subtree value. In that case, we will take the max of the parent branch sum plus price of node, and the max subtree plus price node. This is second. Second means the other value in the pair. Otherwise we will take the first, the max value, and we take either the max branch sum plus price node or max subtree, maximum subtree plus price node. And again, the time complexity for this is big O of n.